Now, girls, this is exercise 9E again, question 8, okay? It says the line y equals 2x plus 10 is a chord of the parabola x equals 4t, y equals 2t squared. Now, this is x equals 2at, y equals at squared. It looks like a is 2. Remember, the parabola is of the type x squared is 4ay. We know that a is 2. This is the parabola x squared equals 8y, okay? Now, it says that, I'm just doing a quick sketch of what this is. This is y equals x squared on 8. It's like a parabola like this. I haven't got any specific points, but they're saying that the line y equals 2x plus 10 is a chord of that parabola. I'm not sure exactly where all these points are, but I'm just going to say, let's just say this is the line y equals 2x plus 10, for example. It obviously cuts the parabola in 2 points. Now, it says by putting the line in this form, y equals a half p plus q times x minus apq, this would be, now this line is a chord of the parabola. I'm going to give these 2 points here on the parabola parameters of 2ap, ap squared. This is what it's asking us to do. So it's asking us, like this line is a chord of the parabola. It means that it does cut it in 2 places if it's a chord. So it's saying by putting the line in this form with p's and q's, obviously point p is 2ap, ap squared, and point q will be 2aq, aq squared. And we want the line in that form. Now this is the equation of the line. So what I want you to do is what you've done before in part 7a. Also, I think you did it in question 3. I want you first to find the equation of the chord PQ. Now, please try and do it on your own. This is really good practice. Remember, first you find gradient PQ. So you'll find the gradient of PQ. Then you'll use the point gradient form using either the point P or Q. So once you've done all that, you will get this, that y equals a half p plus q times x minus apq. So you will get that once you've done it. Now, please do that again. I know you might think you've done it many, many times already, but believe me, you need to practice it more than a couple of times. So please derive that from the points P and Q. Gradient of PQ and point gradient formula to give you this. Now it says that this line is also a chord of that parabola, so we've got this as equation 1, that's the chord, but we're saying, well, really, that chord is actually y equals 2x plus 10. Now what I'm going to do, I just want to equate coefficients. So equating the m and b of the equation, you know, the coefficient of the x and constant terms. So equating the coefficient of the x and the constant term, I'm going to get that the half bracket p plus q, whatever's in front of the x here, equals 2. And I've got that minus apq is equal to 10. So I'm going to call these equations 3 and 4. Okay? So it says by putting the line in this form, which we've done, and this is that same line, find p plus q and p times q. Okay? So looking at this, what would p plus q be? P plus q would just be 2 divided by a half, or 2 times 2, which is 4. Because a half of 4 we know is 2. But we go 2 divided by a half, or this is p plus q over 2. To get rid of divide by 2, we times by 2. So therefore we get that p plus q is 4. And here we can see that negative a pq equals 10. So therefore PQ is 10 over negative A. Now we know from earlier that A is equal to 2 from up here. So therefore P times Q is 10 over negative 2, which happens to be negative 5. So therefore P plus Q is 4 and PQ is negative 5. So that's our answer to question 8, part, just having a look at it, question 8, part A. Actually, still not finished. And then it says, and hence find the coordinates of the endpoints of the chords. So if we know that P plus Q is 4 and P times Q is negative 5, the only way that we're going to find 2AP AP squared and 2AQ AQ squared is if we find out what P and Q are. And we can find those out by solving these 2 equations simultaneously. Now I know you know how to do that. So why don't you pause the video, try that on your own. And then restart the video when you're done. So P plus Q, just starting off from, I'll call this equation 5. P plus Q is 4, equation 5. P times Q is negative 5. equation 6. Let's rearrange equation 5 and make it that Q is 4 on P. We're going to sub into equation 6. No, we're not. We're going to sub it into equation 5. So Q is 4 on P. We get P plus 4 on P is 4. Now, that will be a quadratic when you multiply through by P. And you get P squared plus 4 is 4P. You can clearly see it's a quadratic now, so taking everything over to the left, and don't think this factorizes somehow. We'll just have a look. Back, I have just found a little error again. It's obviously getting late. Rearranging 5, sorry about that. I'll just stop here. Rearranging 5, I get that Q is 4 minus P. Sorry about that. So therefore, subbing in 6, I get P times 4 minus P is negative 5. This is better. 4P minus P squared is negative 5. Taking everything over to the right, we get that P squared minus 4P minus 5 equals 0. Now this looks factorizable. P minus 5 times P plus 1 equals 0. Therefore, P is 5 or negative 1. Now looking at our parameters, remember P is the point 2 AP squared. Now, if P is 5 or negative 1, what you're going to find is actually that P is 5. When P is 5, if you go back into your equation up here, see if P is 5, Q is negative 1. So if we've got P is 5 or negative 1, we can call, if we look at our graph, where 2AP AP squared, this P here must be where P is 5, because that would give us, remember, and that A is 2. So going back and looking up here, I'm just going to do it here. If you substitute P is 5 and A is 2 there, you get P is the point 20, and AP squared will be 2 times 5 squared. 2 times 25 is 50. So I'm getting that the point P is 2050. Now for Q, we substitute negative 1. So what I've really got here, looking at where P and Q are on the diagram, I've got that P is 5, but here the point Q will be negative 1. So if we substitute Q is negative 1 and A is 2 into those points, you're going to get that this point 2AQ is 2 times 2 is 4 times negative 1 is negative 4. And AQ squared will be 2 times negative 1 squared is 2 times 1 is 2. So we end up with the points P and Q being, so therefore point P as shown above will be the point 2050, and point Q is going to be the point, sorry you can't see that, and point Q is going to be the point negative 42. Okay, so look here, I noticed I'd done something wrong. It really wasn't working. It's not meant to be that hard. So I just stopped, looked back, and realized that I'd made an error. So you need to do a similar thing in an exam when you're getting tired. If it doesn't look like it's coming out to be quite easy, just stop and just go back and have a quick check, because, you know, more times than not, you will have made a mistake, all right? Okay, that's that for question 8. Now you might try questions 8B and C in your own time, okay? So similar method to what we've just used above, so you can try out questions 8B and C. We're now going to look at question 9. Question 9, they're saying using the equation y equals a half P plus Q times X minus APQ. Hopefully you've recognized that as the equation of the chord PQ for the parabola x squared equals 4ay. So it says, using that equation, show that the midpoint of a chord of the parabola x equals 2at, y equals at squared. We know that that's the parabola x squared equals 4ay, because if you make t the subject, you get x is 2a, 2 on x, no, t is x on 2a. You put that in there and you will end up with x squared is 4ay. So it's saying that the midpoint of the chord PQ lies on the vertical line x equals k if and only if the chord has gradient k over 2a. Well, let's just see what we can do. I'm just going to put point P here and point Q there. And it says the midpoint here, I'm going to call that M, and what we need to do, obviously, because the question's referring to the midpoint of PQ, of that chord, we should find the midpoint of PQ. Okay, so we're going to do that first. So you can try that. The midpoint, remember to find midpoint. You add the x values together, divide by 2, and you add the y values together and divide by 2. So please pause the video and restart when you're ready. So remember, midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, I'm finding the midpoint. We've got, we can call this x1, y1, x2, y2. We get 2ap plus 2aq over 2, comma, ap squared plus aq squared over 2. Now we can take out 2 as a common factor from here, so 2ap plus aq over 2. And there really is only a as a common factor here. Actually, I could take out 2a here, looking at that now. So I've got 2a bracket p plus q over 2. And here I can take out just an a, so a bracket p squared plus q squared over 2. So I'll just write that more clearly. Get rid of the 2's now. The 2's cancel, and we get a bracket p plus q, comma, a p squared plus q squared over 2. So this is the midpoint of PQ. Now it says, using that equation, show that the midpoint of a chord of the parabola x equals 2at, y equals at squared, lies on the vertical line x equals k, if and only if the chord has gradient k over 2a. So I think what we need to do next, they're referring to the gradient of chord PQ, so why don't we work that out, okay? I go and work out the gradient of PQ. If this is the equation of PQ up here, because we've recognized this as the equation of chord PQ, then the gradient of PQ is a half bracket P plus Q, because this is in the form y equals mx plus b, okay? So we don't want to go doing that because it's actually already been done. So here we've got the midpoint of PQ and the equation of PQ. Now it does say, using the equation, show that the midpoint lies on that vertical line if and only if the chord has gradient k over 2a. So we know that this lies on that line, so we might try substituting it into the line. I'm not sure if it's going to work, but let's try that. So we're going to sub that point into the equation of PQ, okay? So we've got y is a bracket p squared plus q squared over 2 is equal to a half bracket p plus q. Here is the x. Remember, m is the midpoint and it lies on that line, so I can substitute it into it. So I've got a half bracket p plus q. Now I'm substituting the x value, which will be this, bracket a times a bracket p plus q. So I've got y equals a half p plus q, then this is the x minus apq. Now I've got a bracket p squared, sorry, just running out of room. Now we're just going to manipulate this a bit. A bracket p squared plus q squared over 2 equals a half. Now this is obviously p plus q times p plus q, which is p plus q squared, and it's times an a. So I'll put this a here, minus apq. Actually, this is leading me nowhere, because I know when I expand that, I get p squared plus 2pq plus q squared. It's going to be similar. I think just this left-hand side and right-hand side are identical, so that's actually not helping me at all. And look, I'll just do it anyway to show you. So I've got a over 2, p squared plus 2pq plus q squared. Now this is minus apq, but that's not over the 2. But if I want to put it over the 2, I'd go minus 2apq. We can see this is just a, looks like I've got p squared plus q squared. I want to pull this 2apq outside. So I'm just pulling that out of this bracket, minus 2apq over 2. Notice I've just got the same as that, so there's no point doing this, all right? Now I wanted to show you that because sometimes you'll do that and just end up nowhere. So not a good idea to put that into the equation of the line. It doesn't get me anywhere. We do know that the gradient of PQ is a half bracket P plus Q. So if it says if and only if the chord has gradient K over 2A, why don't we try and make this, and we'll say that the gradient of that is K over 2A. Let's just see what we can do there, okay? I suppose we can say that P plus Q, putting that 2 up there, is 2K over 2A. Okay, so P plus Q is K on A. Okay. Oh, yes, now what we can do, yes, we've done that. Sorry, I've run out of space. Now, we know that the midpoint here was A P plus Q, comma, A P squared plus Q squared over 2. So, it said, show that the midpoint of a chord of the parabola lies on that vertical line if and only if the chord has gradient K on 2A. So we looked at what the gradient of the chord was, which was here. We've said that, that the gradient of PQ equals K over 2A, which gave us this. We've manipulated that and come up with an expression for P plus Q, which is K on A. Now I've got the midpoint of M, which was done earlier here. I'm going to replace the P plus Q, or substitute P plus Q with K on A. So therefore the midpoint is A times K on A, comma, A P squared plus Q squared over 2. Now the A's cancel, leaving 1, so we get that the midpoint is K, A, P squared plus Q squared over 2. So therefore that midpoint, because it's got coordinates K and something, I'm going to write those coordinates up here. So the midpoint, therefore, the coordinates of that are K, and I think we had A bracket P squared plus Q squared over 2. Therefore, M must lie on the vertical line. This is a vertical line of M equals K. So we've done it. Oh, sorry, not M equals K. It lies on the vertical line X equals K, because M has coordinates K and this Y coordinate here. M lies on the vertical line X equals K. Okay, so that one's done eventually. Did end up nowhere in this middle section down here, but that doesn't matter. If you see you've got a dead end, go back, read the question again, okay, and then use the information that's given, okay? Obviously substituting something into this particular line here, because it was actually derived from the points on the line, that's why it ended up with equal expression on the left and the right, so that didn't work at first. Question 10, points P, Q, R and S lie on the parabola x equals 2at, y equals at squared, and they have parameters P, Q, R and S respectively. If the chords P, Q and RS intersect on the axis, show that the ratio of P to R is equal to S to Q. Now look, we know that this is the parabola x squared equals 4ay, so it's concave up. Now I'm just going to draw in the points P, Q, R, S just like this. So I've got P, Q, and it doesn't matter exactly how they're drawn, R, S, okay? They intersect on the axis. What they mean by the axis is the axis of the parabola. In other words, the axis of symmetry of this parabola is the y-axis. So these chords will intersect where x equals 0, so you'll use that. So with this question, obviously your points P is 2AP, AP squared. Q is the point 2AQ, AQ squared, okay? R is the point 2AR, AR squared. And S is the point 2AS, AS squared. Now, the chords P, Q and RS intersect on the axis. You're going to have to find the equation of the chords PQ and RS. Now, just find the equation of chord PQ. You will end up getting this, and we've done it so many times, y equals a half P plus Q times X minus APQ. Now, I want you to do that. It's really good practice. Remember, you find the gradient of chord PQ and use the point gradient formula. You can then find the equation of chord RS. Now, you don't need to do that once you've done PQ. You will just replace the P and the Q with the R and the S, as I'm doing here. So P and Q gets replaced with R and S. So here are your equations. Now, they're saying that these chords intersect on the x-axis. So, in other words, point of intersection, which means solve simultaneously. So, girls, you're going to need to solve these two equations simultaneously. Now, we need to solve them simultaneously, but we also know another thing, so we want to solve simultaneously. the other thing we know is that they intersect on the x-axis. So if they intersect on the x-axis, on the y-axis, the axis of the parabola, then we can substitute x equals 0, because this point here is 0, y, we don't know what it is, but we can substitute x is 0. So what we're going to do is solve simultaneously, put equation 1 equal to equation 2. So we can put you can just say sub 2 into 1, and you just write, basically, if y equals that and y equals that, you put them equal to each other, okay? The other thing that you can now do is that you know that x is 0, so you can substitute that in. Now that wipes all of that out. So you get minus APQ is equal to, now we know x is 0 here, so this all gets wiped out, equals minus ARS. Now we can swap sides and we will get APQ equals ARS. We can divide through by A and we get P times Q equals R times S. Now that's P times Q equals R times S. Now what you can do, you just have to show that the ratio of P to R is equal to S to Q. Now that means, let's keep the P here. Instead of times Q here, we're going to divide by Q. We're just rearranging this. So we get therefore that P over R, so the R is going to go down there and the Q is going to go down there, is S over Q. So we're just rearranging that. Or what we're really doing is dividing by Q, dividing both sides by QR. So if I divide that by QR and divide this by QR, I will get S over Q equals P over R. And remember, fractions can be written as ratios, so P over R can be written as P ratio R equals S ratio Q. And that's done. Okay, girls. I'll just see what I'm going to set you for homework now. I really don't think you need to do any questions from the textbook, but I'll just have a quick look, okay?